Hi students, this is Mr. Yao. Today we're going to talk about 9.1, where we will learn about trigonometry functions. We will learn 6 different ratios. But before we do that, let's start with some prior knowledge. Let's review Pythagorean theorem. This time, instead of actually rounding the answer, we are going to keep them exactly what they are and simplify the radicals if we need to. So number 1, you're going to see the right angle right there, and that means the sides next to them, the right angle, their legs. So it's 24 squared plus x squared. The left side, which is 26, is the hypotenuse. So we got 576 plus x squared equals 676. X squared equals 100. Square root both sides, x is 10. Next, number 2. We got square root of 13 squared, square root of 10 squared equals x squared. 23 equals x squared, and x is square root of 23. Don't forget a unit. Next, number 3. X squared plus 7 squared equals square root of 126 squared. That is x squared plus 49 equals 126. X squared equals 117. And that cannot be simplified when you square root it, so x is square root of 117 meters. Number 4. If you forgot how to check if something is a right triangle or not, we're still going to use Pythagorean theorem. It's just we don't know if they're actually equal to each other. So we're trying to see if a squared plus b squared equals to c squared or not. And our c is always the longest side. So in this case, that means that a and b is 8 squared and 12 squared. We're trying to see if it actually equals to 4 squared 13 squared. The left side is 64 plus 144. The right side is 208. So together, that's 208 equals 208 or not. And in this case, clearly they do. So yes, it is a right triangle. These are the prior knowledge. Now let's actually start using them in trigonometry. Trigonometry is the study of a right triangle, and it's not even just right triangle. It's actually anything with an angle that involves shapes like triangle. And you do know all the polygons come from triangles, so that means we can learn any shapes. And here's the breakdown of the word trigonometry. Tri means 3. Gon is like polygon, pentagon. It actually means angle. Trigonometry means the measure of something or the metric. So that's what trigonometry actually means. Now let's define some new sides in a right triangle. We already know the hypotenuse. That's something we have been using, hypotenuse. The other two sides, we used to call them legs. Now they're different. We call them adjacent and opposite. You also see this new symbol because we used to use capital letters to represent the angles, but in trigonometry, we typically label the angles inside. And we use Greek letters to represent alpha, beta, and theta. So alpha, if you want to practice writing it, is like that. It's kind of like letter A. Beta is similar to letter B, but has a tail, and we actually go from the bottom. And theta is a circle with a little line inside, not a circle, an oval with a little line inside. Alpha, beta, theta, we also have gamma and more. And we use these to represent angles. Hypotenuse is the side that's facing the right angle, we already know that. Adjacent side, this is where things get a bit slightly tricky. Adjacent side and opposite side actually are depending on where our angle is. So adjacent side means the side that meets the hypotenuse to form the angle, or just like the word adjacent, it means next to. So whichever angle we pick, this is the angle we pick, our theta, and that is our adjacent side, the side actually next to the angle. And as for the opposite side is actually facing whatever angle we pick, which means in this case, if we actually have this angle as our theta, then the adjacent side would actually be this one, and the opposite would actually be AC. So make sure you're very clear on which angle we pick, and based on that, then you will know your adjacent side and your opposite side. Now let's have a look at the 6 trig ratios we are going to learn. The first 3 are the main ones, so let's have a look. We have sine, cosine, and tangent. When we have these ratios, they actually mean the length of opposite side over the length of the hypotenuse. If you're having a hard time to remember them, I will teach you a little trick that can help you to remember these three in a minute. But the main idea is sine is the facing one opposite of the hypotenuse, cosine is the adjacent one hypotenuse, and they both have hypotenuse. Tangent is the one that doesn't have hypotenuse, opposite over adjacent. Then we have another three, and they are cosecant, secant, and cotangent. And you can see the ratio is being formed there. The cosecant is basically just sine with the fraction, which is why cosecant is 1 over sine. And secant is 1 over cosine. Because it's hypotenuse on the top, adjacent on the bottom, we just flip the cosine. And cotangent, of course, is going to be flipping the tangent, so it's 1 over tangent. But like I said, we actually just need to remember the first three, then the other three should actually come after. So here's what we commonly use to remember the ratio. We call that SO, HOA. And the SO, if you actually have a look at it, it is SO H. So just means sine is opposite over hypotenuse. And then, of course, we have a K, which is C representing cosine, and that is adjacent A over hypotenuse H. So that's K. Lastly, we have TOA, so T is tangent, and then O is opposite, A is adjacent. So that's how SOHCAHTOA works, and you might want to start repeating them whenever you do a question to find the ratios. Just repeat SOHCAHTOA, it should actually help a lot. Next, here's what I want to mention. If you look at a letter S, that is being together with letter C, and they are actually reciprocals. Okay. And then we also have this cosine, that is being paired up with another S. So the key to remember these is you actually never use the same initial for the pairs. S is with C, E is with S, E is with C, and they're all reciprocals. Now let's move on to practice identifying some of these ratios inside triangles. So example 1, our angle is right here, and we want to actually identify our opposite, adjacent, and hypotenuse. So opposite is the one that's facing it, so 3. Adjacent is the one that's next to it, so 4. And hypotenuse is the longest side, so then we can identify our sine, cosine, and tangent. So, TOA, let's use that. So opposite over hypotenuse, so opposite of 3, hypotenuse is 5. CAH, A is adjacent, so 4, hypotenuse is 5, so 4 over 5. And tangent, that's TOA. O is opposite, so 3 over adjacent, which is 4. And next, the other three ratios. Cosecant is just sine flipped, so it's 5 over 3. Secant is cosine flipped, so it's 5 over 4. Cotangent is tangent flipped, so it's 4 over 3. Example 2. You can use example 2 to practice, see if you understand it, and then you can come back and check the answers. Opposite, right there, that's 8. Adjacent is the one next to it, so 15. Hypotenuse, longest, 17. Sine, so is OH, so 8 over 17. AH, 15 over 17. Tangent is OA, so it's 8. Now we just need to flip them to get the other three. 17 over 8, because it's related to sine. 17 over 15 related to cosine. 15 over 8 related to tangent. Next, example 3. This time, you see we're given two sides, but we don't know the third one. However, just like in the prior knowledge, if we know two sides of a right triangle, we for sure can find the third side using Pythagorean theorem. I'm going to save that process. We will get this side is actually 2 square root of 22. So opposite, we get 9. Adjacent, 2 square root of 22. And then hypotenuse is 13. Sine, so OH, so it's 9 over 13. AH, so it's 2 square root of 22 over 13. Tangent is over, so 9 over 2 square root of 22. Cosecant, flip it, so 13 over 9. Cosine, flip it, 13 over 2 square root of 22. And cotangent, flip it, 2 square root of 22 over 9. One last thing. You'll recall, we have learned about radicals in unit 2. And we have learned we cannot have a radical on the bottom of the fractions. So that means there are some things we need to do. We need to simplify tangent and in order to get rid of the square root of 22, we are going to multiply both the top and the bottom by square root of 22. So this whole thing will actually just become a 22 on the bottom. So it's 2 times 22, which is 44, and the top is 9 square root of 22. Same thing with secant. Multiply the top and the bottom by square root of 22. That's going to be 13 square root of 22 over 2 times square root of 22 times square root of 22, which is 44. That's example 3. Next, example 4. We know it's 7 and 8. So 8 is the facing, so it's opposite. 7 is next to theta, so that's the adjacent. We can still use Pythagorean theorem to find what is the hypotenuse. Sine is opposite over hypotenuse, so 8 over square root of 113. Simplify it. Multiply both the top and the bottom by square root of 113. So it's 8 square root of 113 over 113. Cosine 7 over square root of 1 is 3, which is the same as 7 square root of 113 over 113. Tangent opposite over adjacent, so 8 over 7. Same idea for cotangent, flip the fraction 7 over 8. Secant, flip the fraction is square root of 113 over 7, and cosecant is square root of 113 over 8. These are the 4 examples about identifying trigonometric ratios. Now let's do something else. Use your calculator to find each value and make sure you actually round to the thousands place. So this time things are slightly different. We're going to use a calculator. But before we actually do that, there's something else. On our calculator, we have something called mode. And that's the button we're going to need to always check to make sure. So let me actually make sure this is in front. And next, we're going to need to make sure our mode is on the right one. So click on mode. Normal, scientific, English, we don't need that. The one we need is radian. So we're going to go down to radian and go to the right, click enter. This makes sure our mode is currently on degree. And that is what we need to find these ratios. So first one, sine 9 degrees. You will see sine right here. So type in sine 9 and press enter. That is going to give you to 3 decimal places, 0.156. Next, we have cosine. So cosine, and it's 55 degrees. That is going to give you 0.57. Next, sine. Again, so sine negative 37. That is going to be negative 0.60. Tangent is still on our calculator. Tangent, that's got to be 72. Tangent 72, which is 3.077. Which is 0.78. Cosecant. This is where things get a bit tricky. We're going to need to make sure we understand. Cosecant, on the previous slide we had talked about, is actually 1 over sine. We don't have a cosecant on our calculator, so in order to find it, we're going to need to do 1 over sine. So now let's type it in. It's going to be 1 divided by sine 90. Press enter. That is going to give us a 1. Secant, we're going to do the same thing. Is 1 over cosine 48 degrees. And so we type in 1 divided by cosine 48 degrees. And that is going to give us right here 1.494. Okay, so for the non-common ones, we're always going to use the reciprocal to find it. So cotangent 120, we are going to do 1 divided by tangent 120. That is going to give us negative 0.577. Next, secant, that is going to be 1 over cosine 30 degrees. So we got 1.155. Oh, that just, okay. Last one is cosecant. So we're going to use sine 1 divided by sine 3 degrees. That is going to give us 19.107. Okay, make sure you know how to use your calculator to find these values. Now moving on. And this time we actually have a ratio, but we don't have a triangle. So we are going to need to draw a triangle. All right, triangle. And it doesn't quite matter where you pick the angle theta. It's just your adjacent side and your opposite side is going to change accordingly. So I'm going to say this is my theta, and that is cosine, which is adjacent over hypotenuse. So the 7 is adjacent, 7. Hypotenuse is 9. In this case, we can actually find our third side. This question now is very similar to example 3 and 4. So if that's 9, that is 7. We're going to get this side as 4 square root of 2. Sine is opposite, so 4 square root of 2 over 9. Tangent is opposite over adjacent, so it's 4 square root of 2 over 7. Secant is actually 1 over cosine, 1 over cosine, which is 9 over 7. Cotangent is 1 over tangent, and our tangent is actually 4 square root of 2 over 7, so flip it. 7 over 4 square root of 2. Don't forget to simplify your radical. That is going to be 7 square root of 2 over 8. That's example 6. Example 7. We're going to still need to draw a triangle. So let's say this is my angle theta this time. And it's tangent, so we have 5 over 12. After solving, we can find the third side using Pythagorean theorem, which is 13. Sine is opposite over adjacent, so opposite over hypotenuse, 5 over 13. Cosine adjacent over hypotenuse, 12 over 13. Cosecant is actually 1 over sine, flip it, 13 over 5. Cotangent is 1 over tangent, which is the opposite of tangent, so in that case, 12 over 5. Last thing. Trigonometry is actually very commonly used in a lot of ways. We can use them for measuring the height of the building, and we can use physics. If in the future you're thinking about getting into engineering, you're going to be using a lot of trigonometry. So as long as you have an angle, you can actually use trigonometry to find something. And that now is everything for 9.1. Thank you.